Alrighty, here's the short answer portion of your test you just took. Two students, Brandon and Chris, have volunteered to be launched horizontally with different speeds from the top of a 70-meter cliff into a lake below. Brandon's launch speed is 2.5, while Chris's is 3.4. What's the different distance between Brandon and Chris when they land? So the fact that these are horizontal projectiles is very important. That means their VIYs are 0. Their accelerations are negative 9.8. Their delta y's are both negative 70. So we can find the time that they're going to have, and their times in the air are going to be the exact same because they're falling the same distance from a horizontal shot. So we can do, to find their times, delta y equals VIYT plus 1/2 AT squared. Make sure you use negative 70 as your delta y. Solve for time. You get 3.78 seconds. That's for both. Now their ranges, you just multiply that time by their Vx. So if you multiply 3.78 by 2.5 and by 3.4, you get their two ranges, subtract them, and they're 3.4 meters apart when they land. 27, a stone is thrown at an angle 30 degrees above horizontal from the edge of a cliff that's at 12 meters per second. If the height of the cliff is 120 meters, what is its range? So how far away does this thing land? So you need to find the x and y components. The y is 6, the x is 10.39. Your delta y is going to be negative 120, so that's how you're going to get the time. Acceleration y, VIY is 6. So you can solve for time using delta y equals VIYT plus 1/2 AT squared. You're going to have to use a quadratic equation. You get a time of 5.6 seconds to land. So then you take your x velocity, which is 10.39, and you multiply it by this time of 5.6 seconds, and you get a range of 58.2 meters. Cristiano Ronaldo takes a free kick from 30 meters away from the goal. He kicks the ball with a speed of 21 meters per second at an angle of 25 degrees. You're trying to figure out, does the ball go in the goal or does it go over? You're given the range, which was 30 meters from the goal, and you have enough information to get your Vx. So break this into components. You got 19.03 meters per second in the x, 8.87 meters per second in the y. So you can take your range and divide it by your x velocity to get the time it takes the ball to get to the goal, and that's 1.58 seconds. Then you know that time, you need to find the height. If the height is less than the 2.4 meters, then it goes in. If it's more, then it goes over. So I'm going to solve for delta y using this time. So VIY is 8.87 times 1.58 plus 1/2 negative 9.8, 1.58 squared. You get a delta y of 1.78 meters, which means the ball's definitely going to go in the net. Number 29, the Headless Horseman is sad that Halloween is over. He decides to take his frustration out on Ichabod Crane. He picks up a pumpkin and throws it at Ichabod at 10 meters per second at some angle theta. It hits Ichabod, who's standing 9 meters away, so there's your range. After being in the air for 1.05 seconds, at what angle did the Headless Horseman throw the pumpkin? So you're given the range and the time. So all you can do is divide to get your velocity in the x direction. So that velocity in the x direction has to be 8.57 meters per second. So that gets labeled on the x side of this triangle. And then you can use cosine to get the angle. Cosine of theta equals 8.57 over 10. So use your inverse cosine, and you get 31 degrees. So for the bonus problems, we had a couple people get them right, which is great. A lot of people were really close. So the first one, you're shooting actually down at 400 meters per second at an angle 20 degrees below horizontal. So you can find the x and y components. You've got 375.9 and 136.8. It also says that she's moving away from her target horizontally at 30 meters per second, so that's going to affect your x velocity. It says that she hits a target 260 meters downrange, so that's your range. Your x velocity is actually going to be 375.9 minus this 30 meters per second that they're driving away from the target. So if you subtract and then divide, you get a time of 0.752 seconds for this shot to hit the target. Now you can find delta y using your VIY, which would be negative 136.8. A lot of people are missing the negative sign there because you're shooting down. Times 0.752 plus 1/2 negative 9.8 0.752 squared. So for that, you get negative 105 meters. So she's 105 meters above her target. And then the bonus number 2, we had one person get right. I'm not going to walk through the explanation there. It involves substitution like your bonus problems did. It was 8.13 meters per second.